The topic of discussion is power of lenses. Have you heard of people talking about what is their power of their spectacles? It's the same thing. Okay, so that's what we are trying to understand. So, in the most simplest manner that I would define is how near can the lens diverge or converge a beam of light. So let me show it to you. I'll be showing you two lenses, right? You guys have to figure out, keep this in mind, okay? Keep this in mind. You guys have to figure out which has more power. So please have a look. So we have lens 1 and 2. Okay, so please make a note of that distance, right? So I had two lenses in my hand. Obviously you can see the image. So this was lens 1 and this is your lens 2. So you can see the convergence of the source, and source being what? Source for both being sun. So the distance of the object is fixed. U is fixed for both. U is fixed. Right? While V is different for both. V for first lens is smaller than V for second lens. As per this understanding, which has more power? Lens 1. Okay, so lens 1 has more power. Right? And by the way, what kind of lens are this? Concave or convex? Yes, both are convex. Now, as a definition, it's quite simple. It is a reciprocal of its focal length. That's it. I'm not joking. That's the definition. How do you represent it? With the letter P. What is the formula? So the formula is 1 by F. That's it. Provided you express F in meters. But what if we have it in centimeters? Then you can use this formula. This is the official formula, the first one. The second one is from my end so that you guys can use it in your exams. Next thing that we need to know is the SI units. So SI unit of power is diopter. Power of lens, not your electrical power. Power of lens is diopter. So this is named after a person. That's why we have capital D. Okay, like Newton, we have capital D over here. If not, you spell it in this manner. So defining one diopter is quite simple. So we know that whenever you have to define, you always have to go back to your formulas. So if we need one diopter over here, it is 1 divided by 1 meter. 1 divided by 1 is 1. So 1 diopter is a lens which has a focal length of 1 meter. Right? Now, let us find the power of two lenses that I showed it to you guys. Okay, so I'll be showing it to you guys. You have to figure out. Again, you guys have to figure out. So after watching the practical video, you guys have to make a note and do the small calculation. So please have a look at the video. So here I have your screen and those are your lenses. Lens number 1. So when we get a sharp image, I stopped at 10 centimeter. So I'm changing the lens. So the same screen. So the source remains the same. Lens number 2. I got a sharp image and make a note of the distance. 14 centimeter. Okay, one was 10, other was 14. Right? So now you guys have to do this calculation. Pause it now. Do this calculation and let me know. So the first one was of focus 10 centimeter. The one which we measured was the focal length, not radius of curvature. Okay, that was the first thing that you had to note. Next thing is the sign. Is it positive or negative? We got a real image, so it has to be convex. So it is positive. Next, the formula is 1 by F if not 100 by F if it's in centimeters. So this will be 10 diopter. Second one, we saw the focal length of 14 centimeter and the formula is 100 by 14. So this is approximately 50 by 7, that is approximately 7 diopter. Okay, so this is something that you guys have to keep in mind, that sign convention is applicable over here also. So I'll be talking about that. I hope you guys got a good idea about power. It's very simple. I just made it a bit lengthy. So pause and make a note.